Hello everyone, Mrs. Hoekstra here. Module 3, Lesson 2. I'm on page 8. Lesson 2 is Generating Equivalent Expressions. You'll notice the essential question, what operations must be rewritten before any regrouping can be done? Right? What has to get rewritten before I can regroup and put everything together? And on page 8 here is an opening exercise. We're going to save that for in class. All right, we're going to do this in class. Do in class when you come in. All right, so just skip this page. Let's go to page 9. Skip right on over. We're going to start with example 1 here. It says talking about subtracting expressions. All right, so we're going to just take this, and it wants us to do this 2 different ways. One way using SMATO. I know it says sum of this, the opposite of the sum is the sum of the opposites, but it's basically SMATO. All right, and then the other one is order of operations, just going and following, please excuse my dear Aunt Sally. So I'm going to split my paper, my spot here, into 2 parts. So the first one is going to be SMATO. I'm just going to write SMATO across the top here. Just following that concept of SMATO. So let's take, we have 40 plus 9, that looks like an A there, 9, minus 30 plus 2. All right, now SMATO says subtraction means add the opposite. So everything in the front stays as is because I'm not doing anything to it, but subtraction means add the opposite. So I'm going to add, and what's the opposite of 30? Negative 30. What's the opposite of 2? Negative 2. So I'm going to add the opposite. Okay, now I can basically just add. I don't need the parentheses there if I don't want to. So 40 plus 9, I might as well just make this 49 plus negative 30 plus negative 2. Maybe I'll just put my negatives together. You know what? I think I'll do that. I'm going to erase those. Let's put our negatives together as well. And that's negative 32. Now I've got signs that are opposite. Which one's bigger? 49 is bigger, so I'm just going to do 49 minus 32 over here on the side, and I get 17. The sign is going to be positive because 49 was the bigger number and it's positive. Okay, now the other side, the other way says to do this, they want us to just use order of operations. Order of operations. And so what they're saying is literally follow, please excuse my dear Aunt Sally. So I'm going to start out by writing the problem. 40 plus 9 minus 30 plus 2. Okay, please excuse my dear Aunt Sally, parentheses have to come first. So I'm going to work inside my parentheses. So 40 plus 9 is 49 minus the other parentheses, which is 30 plus 2, which is 32. This is just a simple subtraction problem. 49 minus 32 is positive 17. Well, right now you're like going, well, gee, that way was a lot easier. You're right. It probably was easier in this particular case. There are times when it's going to be easier to do the SMATO. There's going to be times when order of operations is actually going to be easier. And it also depends on just which way your brain sees how to work these out. However, things change when I start putting in variables. Okay, so I'm going to go through this process again. Okay, let's put SMATO on this side. And let's put order of operations on the other side. And let's go ahead and work this out. So I've got what? 3x plus 5y minus 4 minus everything in the parenthesis over here, 4x plus 11, right? Just rewrote the problem. SMATO says turn everything after the subtraction sign into adding the opposite. And if I want, you know what? Maybe I'll just even do that to the 4 too. So I have 3x plus 5y plus, add the opposite of 4, which is negative 4, plus what's the opposite of 4x? Negative 4x. What's the opposite of 11? Negative 11, right? All right, now we can rearrange these using the commutative property. I don't have anything in particular that I need to put it in a certain order, but I'm just going to put the x's out front because alphabetically they come first. Nothing goes with the 5y, so I'll just leave the 5y alone. And then I have my negative 4 and negative 11. I can combine my x's, right? 3x plus negative 4x, 4 is bigger. The signs are different, so I'm going to have a negative 1x or negative x. Nothing gets combined with my 5y, so it just keeps on coming. And then I have negative 4 and negative 11. The signs are the same. So I just add them. 4 and 11 is 15, and they're both negative. Okay? Order of operations says do the stuff in parentheses first. I cannot combine anything in that first set of parentheses, right? 3x cannot combine with the 5y, which cannot go with the 4. None of those can get combined. And same thing with 4x plus 11. Nothing over there can get combined. I really can't follow order of operations this way, like I did in the example just above it. Okay, SMATO, using subtraction means add the opposite, is the only way for us to get through this, right? Not really that easy to do. Okay, so we're just going to move on. Let's look at example 2. Says combining expressions vertically. Okay, so for those of you who remember back in elementary school when you lined your numbers up on top of each other, right, where you had maybe 23 plus 52, right? I remember adding them up vertically like that, and you would do 3 plus 2 was 5, and 2 plus 5 was 7, and you got an answer, right? You put the ones on top of the ones, and the tens places on top of the tens, and the hundreds places on top of the hundreds places. And you lined everything up. You're going to do the same thing here, except you're going to line up the variables, okay? So we're going to start with the first one. We have 5a plus 3b. I am going to change this to plus negative 6c. Okay, I'm going to rewrite that, SMATO that, and then I'm going to add, and then I have 2a, goes right underneath the 5a because they both have the same variable, plus negative 4b, because of course I'm adding, so I'm just going to SMATO this, and then plus 13c. And again, the a's, the b's, and the c's all line up like you would if they had just been a regular old everyday number. Now you'll see I don't have to do that whole move things around commutative property stuff because everything is already lined up on top of each other, right? They all just line up vertically. Very nice and easy. So literally add your 6c and your 13c. Well, the signs are different. 13 is bigger. 13 minus 6 is 7. So I have 7c, right? It's going to be positive. All right. Then I have 3b plus a negative 4b. 4 is bigger than 3. It is negative, so I'm going to have a negative 1b, or you could just say negative b, that's fine. And then 5 plus 2, the signs are the same, so I can literally just add them, 7a. Very nice and easy, right? I don't have to do too much to it. You can write this as 7a plus negative b plus 7c, or you could write it as 7a minus b, forget the plus negative part, plus 7c. Okay, all of these are equal to each other, any of those three. So if this was on a quiz or a test, I would accept all three of those answers. All right, find the difference by aligning the expressions vertically. So now we're finding difference, right? Difference tells me I'm going to subtract. Okay, remember that. So I'm going to subtract these this time. So I'm going to write this out as 2x plus 3y plus negative 4, exactly like we had earlier when I'm going to SMATO this. Then I'm going to SMATO the next part, okay? I want to actually write that out a minute. This would be negative 5x plus negative 2, okay? So I'm going to put the x's where they belong, negative 5x. I don't have a y here, right? No y. So I'm going to skip the y spot when I come up and put it into here vertically, and then I'm going to put plus negative 2 underneath the 4 because those are just numbers by themselves, constants. They have no variables. Okay, it's all right. If you want to put a 0 underneath the 3y, you can. If that helps you and makes it make more sense to you, then go ahead and do that. I'm going to leave it blank, but go ahead and feel free to do that. So we have negative 4 plus negative 3. Negative and negative just becomes more negative. So that's not a problem. So I'm going to just add that, and I get what? Negative 6. There's nothing to add to 3y, so it's just that. 2 plus negative 5x. The signs are different. 5 is bigger than 2, so I'm going to subtract, and I'm going to get a negative 3x. So I could rewrite this as negative 3x plus 3y minus 6. Both of those are equivalent as well. I will accept both of those answers. In fact, I kind of like the second one better just because it's a little less work for me. All right, let's go to page 10 then if you're all set. Page 10, example 3, using expressions to solve problems. Okay, here we go. Let's plug in and kind of make it a little more real world. I don't know how real world this is though. A stick is X meters long. I don't know how long this stick is, right? You're walking through the woods and you're kind of messing around and you find a stick, right? And you don't know how long it is. A string is 4 times as long as the stick, right? So you're now at home with this stick and you're like trying to make something, maybe like a fishing pole or something. And you're going to just make your string 4 times as long as that. So let's kind of identify what's going on here. So X is the string, right? Oh, excuse me, X is the stick. This is the stick length. I don't know how long it is. I just know it's a couple meters long. It's a pretty big size stick. All right. A string is 4 times as long. I want to underline that. 4 times as long as the stick. Well, how long is the stick? It's X. We don't know it. So we're going to say 4 times the stick, right? That's literally what we just underlined. That is the string. The string is 4 times as long as the stick. So then it says, well, if the total length is 15 meters, how long is the string? Okay? I don't care how long the stick is. I want to know how long is the string. All right, so I know that combined, the total length, the total of the string and stick is, there's a keyword, 15. Okay, total tells me I'm going to add, and is tells me an equal. So I'm going to add the stick plus the string to get the total. Okay, stick plus string equals total. Okay, well, how many x's do I have in the first one? I have a 1x there, right? I could just imagine there's a 1 there. 1x plus 4x. How many x's is that? We did this yesterday. 1x plus 4x is 5x. 5x equals 15. Okay, how in the world am I going to get rid of that 5? I'm going to multiply by its reciprocal. Okay, now remember, if 5 is my reciprocal, 1/5, excuse me, 5 is my number, 1/5 is the reciprocal. So I'm going to multiply both sides by 1/5. It is the same as dividing by 5. You can do that as well. Okay, I'm going to imagine that this is over 1, and I'm going to imagine the 15 is also over 1. I can cross reduce. 5 goes into itself once, 5 goes into 5 again once. I just basically get a 1x, which is what I want. So I have x is equal to, and on the other side, 5 goes into itself once, and 5 goes into 15 3 times. So my final answer is 3. However, x is the stick length. I didn't ask how long is the stick, I asked how long is the string, right? How long is the string? So the string, right? So x is the stick, but the string is 4 times that, or 4 times 3, which is 12 meters. This is the string. So the string is 12 meters long. It's actually quite long. It's longer than the classroom. Okay, that is over 36 feet. So it's bigger than our classroom. It's a good size piece of string here. All right, let's take a look at example 4. It costs Margot a processing fee of $3 to rent a storage unit plus $17 per month to keep her belongings in the unit. Okay, let's just talk about that. So it's $3, right, up front, and $17 per month to keep the belongings in the unit. So I think what I'm going to do, well, let's just keep reading. Her friend Carissa wants to store a box of her belongings in Margot's storage unit and tells her that she'll pay $1, right? So this is a different friend, a different person. She's going to pay $1 towards the processing fee and $3 every month that she keeps the box in storage. Write an expression in standard form that represents how much Margot will have to pay for the storage unit if Carissa contributes. Then determine how much it is for 6 months. Okay, so step 1, first thing we're going to do, we're going to figure out what we got. What's my game plan, right? In order to find this, I'm going to take what Margot is going to pay, and I'm going to subtract how much Carissa has to pay. Okay, for figuring out exactly how much it's going to be at the end afterwards. If Margot's all on her own, how much is it? And then I'm going to get some variables in here. I'm keeping track of, I'll give you a hint, up here it says $17 per month. And Over here, Carissa is $3 for every month. That right there is my clue that I've got some kind of variable going on. This varies, right? It changes. So the variable in this case is the number of months. So I'm going to use M for number of months. You can use any variable you want. I'm going to use M for months just because it's got the alliteration and kind of makes it make sense to me. All right, let's just look at what's going on with Margot. That's the green part for me. Okay, it says that she's going to pay $3 up front plus, it literally says plus, $17 every month or per month, so 17M. There's Margot. Now, if she is going to rent this all by herself, there it is. I'm done. Boom. But Carissa now comes along and says, well, I'm willing to help pay a little bit if you are willing to let me keep a few things in your storage shed. So we're going to subtract Carissa. Carissa says she's going to pay $1 towards that processing fee, and then she's going to pay $3 every month to hold that box in there. Okay, so there we go. This is how we're going to figure this out. Okay, notice there's no equal signs. I don't know anything else right now. Okay, so let's simplify this because I have figured out that if I simplify it, life is a lot easier. So I'm going to do 3 plus 7M. I'm going to SMATO this plus -1 plus -3M, right? SMATO. Everything inside that parenthesis has to become the opposite. All right, I'm going to rearrange these so that everything is kind of set up nicely. So I'm going to do 3 plus -1 plus 17M plus -3M, right? Commutative property. I just flip-flopped those two around. All right, I'm going to combine my whole numbers, my constants. 3 plus -1. 3 is bigger, so I'm going to subtract them, and I'm going to get 2 plus, and now I'm going to add the ones with the variables on it. 17M plus 3M is 20M. 20M. Okay, simplified it, nice and easy. Oh, Mrs. Hoekstra, you made a mistake. Did you guys see my mistake? Did you guys catch it? I put my negative so close to my 3, I missed it. Oh. See that? I have a negative up above, and I dropped it off. There we go. There's my negative. Signs are different, Mrs. Hoekstra. Pay attention. All right, so 17 is definitely bigger than 3. So I'm going to subtract these. 17 minus 3 is 14M. There we go. That makes more sense. So it's nicely simplified now. Now I'm going to come into that last part. Let's suppose they do this for 6 months. So M equals 6, right? I'm told this right here. So all I'm going to do is I'm going to take that M, I'm going to substitute it in or plug it in, drop it into that spot. So this is 2 plus 14. Anytime you have a number next to a variable, they are multiplied. So times 6. However you want to write times 6, you can put a dot, you can put the asterisk, do not put an X. All right, so now I've got 2 plus what is 14 times 6, right? What is that? 14 times 6, that's 84. And 2 plus 84 is 86. So it's going to cost $86 for Margot, right? Because that's what we want to know. How much will it cost Margot for this? It will cost Margot $86 to rent for 6 months. All right, page 11. We're almost done with this lesson. Here we go. Page 11. Example 5, extending the use of inverse to division. Okay, so I kind of mentioned it a minute ago when I talked about using the reciprocal. Okay, I want you guys to underline, grab your highlighter, do something to make this next little part jump out at you. This first sentence here, multiplicative inverses have a product of 1. Okay, they have a product of 1. That's important for us to understand that. This idea of getting a number to equal 1 is important in algebra. All right, it's something that gets used over and over and over again. Talk to anyone who's gone through math classes, your parents, somebody, maybe a sibling or a cousin who's already in high school or college. They will agree that getting to the number 1 is actually pretty important. All right, so find the multiplicative inverses of the terms in the first column. Show that the given number and its multiplicative inverse have a product of 1. Product, remember, is multiplication. We're going to multiply. Then use the inverse to write each corresponding expression in standard form. All right, so here we go. Notice I gave you the number 3. If I give you the number 3 and write 3 over 1, the multiplicative inverse, you guys also know it as the reciprocal. Okay, maybe you want to jot that down, reciprocal. Another way to think of that, right? So if I take 3 times 1/3, and let's put that over 1. If I take that, I end up getting 3 over 3, which ends up equaling 1, okay? Or if you like the cross-reducing idea, right? 3 goes into itself once, 3 goes into itself once. Now I really end up with 1 over 1, which equals 1. So for those of you who understand that cross-reducing, go for it. If you don't, just multiply across like it was originally in this problem. All right, so if I give you the number 5 and I ask you, what is the reciprocal of 5? Hint, whole numbers can always be put over 1. So what's the reciprocal of 5? It's 1 over 5, right? Just flip it, make it do the handstand. All right, so it's then proof. Show that this actually works. So I'm going to take 5 times 1 over 5. Of course, I'm going to rewrite 5 as 5 over 1. And then I'm going to multiply across. 5 times 1 is 5. And 1 times 5 is 5, right? Just multiply straight across the top, across the bottom. And 5 divided by 5 is 1. For those of you who like to cross-reduce, you would cancel out the 2 5s and you would get 1 over 1. All right, so let's prove that this actually works. 65 divided by 5. I could rewrite this as 65 times 1/5. Okay, now I'm going to put 65 over 1. Okay, and then what I'm going to do is I'm going to cross-reduce. I know 5 goes into itself once, and I know 5 goes into 65 13 times. So I end up with 13 over 1, which is just 13. If you had gone and multiplied across, right, you had not cross-reduced. Those of you who don't do that, that's fine. 65 times 1. Oh, I'm going to sneeze. Oh, I am so sorry, guys. I apologize for that. That was probably really loud. 65 times 1 is 65, and 1 times 5 is 5. You're still going to get the same thing. 5 goes into 65 13 times. All right? So it just depends on how you want to do it, if you want to cross-reduce right away or at the end. It really is up to you. All right, well, take a look at this next one. It is already a fraction. So all I have to do is flip it. What is the multiplicative inverse of -3/5? It is -5/3. Okay, just take it and flip it. Let's see if it actually is the multiplicative inverse. So let's take -3/5 and let's multiply it by -5/3. I am going to multiply straight across. -3 times -5 is +15. +5 times +3 is also +15. 15 divided by 15 is 1. Yes, it works. For those of you who want to cross-reduce, okay, -3/5 and -5/3, right? Cross-reducing, -3 goes into +3, -1 time. +5 goes into -5, -1 time. And so I actually end up with +1 over +1, which of course equals 1. So you can cross-reduce. You're going to get the same answer. All right, so dividing by a number is the same as multiplying by the reciprocal. So I currently have this 6, but I'm not going to divide. I'm going to multiply by the reciprocal, by its multiplicative inverse, so it becomes a -5/3. Now some of you are going, but Mrs. Hoekstra, the negatives with the 3, it doesn't matter. Once one part of the fraction is negative, the whole thing is negative. Okay, so here we go. Multiplying straight across, 6 times -5 is -30. 1 times 3 is 3, and 3 goes into -30, -10 times. Okay, now if you want to cross-reduce, 6 over 1 and -5 over 3, I can cross-reduce. 3 goes into itself once, and 3 goes into 6 twice. 2 times 5 is -10. Okay, Some of you might find the cross reducing to be faster and easier. That's fine. Those of you who don't, no big. All right, now we get the harder parts. 2x. I don't know what x is, but it's not going to confuse me. You know why? Because I know it's a number. I don't know what number, but it is a number of some form. But I also know 2 is a whole number. I can always put my whole number over 1. So what is the multiplicative inverse of 2x? It is 1 over 2x. Okay, just take it and make it the reciprocal. Well, let's check to see if it actually does work. So I have 2x times 1 over 2x. I'm going to put my 2x over 1 because that is totally legal. I multiply across 2x over 2x. What happens when you have a number divided by itself? It equals 1. Again, for those of you who want to cross reduce, if this is how you like to do it, cross reducing, how many times does 2x go into itself? Once, and down here once, and again I end up with 1 over 1. Okay, so let's try this last problem here. 12x divided by 2x. 12x divided by 2x. So I have 12x times the reciprocal, which is 1 over 2x. I'm going to put my 12x over 1 because I can always put a whole number over 1. Multiply across. 12x times 1 is 12x. 1 times 2x is 2x. Okay? What's x divided by x? A number divided by itself is 1. Look at that. I'm going to cross it out, cancel it out if you want, with the number 1. How many times does 2 go into 12? It goes in there 6 times. Again, for those of you who want to cross reduce, right? Those of us who like to cross reduce because it makes it easier, especially when you get really big numbers. Right now these numbers are small, but when you get to these really big numbers where all of a sudden you're working in hundreds and everything, it is easier to cross reduce. How many times does 2x go into itself? Once. How many times does 2x go into 12x? It goes in there 6 times. 6 times 1 is 6. Okay? So hopefully this made some sense to you guys. Multiplicative inverses are extremely important, very helpful for us in class, and I will go over this some more, clarify any questions that you may have. Talk to you later.